The term acid-free is well known in the picture framing industry, but it's often misunderstood and misused. It usually refers to matboards, but some framers mistakenly believe that any materials described as acid-free are the best for protective framing. Tapes and adhesives, as well as framing materials like fabrics, paints, and inks used to create decorative features might be inherently acid-free, or they could contain impurities or reactive chemicals other than acid that make them unsuitable for protective framing, also known as preservation framing. It would be logical to assume that acid-free boards are free of acid, but that's not true. It's a myth. To understand the meaning of acid-free as it applies to mats and mounting boards, it's important to know about the pH scale. Here's a good description given by the United States Environmental Protection Agency, and I quote, "The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14. A pH of 7 is neutral. A pH of less than 7 is acidic, and a pH of greater than 7 is basic. Each whole pH value below 7 is 10 times more acidic than the next higher value. For example, a pH of 4 is 10 times more acidic than a pH of 5, and 100 times, that's 10 times 10, more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more alkaline, another way to say basic, than the next lower whole value. For example, a pH of 10 is 10 times more alkaline than a pH of 9. Pure water is neutral with a pH of 7.0. So a slight difference in pH value represents a big difference in acidity or alkalinity. The pH levels in framing materials can change over time, depending on chemical migration and the interaction of those elements inside the closed-up environment of the frame. Acid is not the only issue to consider. Peroxide and other elements in the board's fibers can chemically react over time as well. So-called acid-free mat boards are made from moderately processed wood pulp containing lignin, an acidic biopolymer, an organic substance that bonds the wood fibers of the tree together. Lignin oxidizes over time, producing acid and other chemically reactive byproducts that could be harmful inside a frame. The oxidation of lignin causes what we call acid burn, referring to discoloration and embrittlement, and it gets worse over time. Eventually, the reactive and harmful chemical elements migrate into adjoining materials or chemically react inside the closed-up frame, spreading the deterioration. Exposure to environmental extremes like high temperature, high humidity, or intense light would accelerate the oxidation of the lignin and the resulting deterioration. Extreme conditions could contribute to other chemical reactions inside the closed-up frame package as well. That's why the conditions for display, storage, and transportation of frames should be controlled as much as possible. In order to counteract the harm of lignin, an alkaline buffer is added to the paper pulp during its manufacture. The buffer commonly used in framing boards is calcium carbonate, which is basically chalk, and also a main ingredient in stomach antacids like Tums and Rolaids. Calcium carbonate is high alkaline, so it counteracts the acid in our stomachs, and it works like that in our framing boards too, where the acid comes from lignin. The buffer is a good defense against acid deterioration for probably a decade or more, but it's not permanent protection. When the acid-free buffered board is new, its pH measured on the alkaline side of the scale, usually with a value of 8 or higher. Over time, as the lignin oxidizes, it uses up the buffer. The pH value eventually diminishes past the neutral value of pH 7 and continues farther toward the acidic side of the pH scale. As the buffer wears out, the acid from lignin causes the board to discolor and become brittle. Acid-free is probably not the best term to describe these boards because the acid-bearing component, lignin, remains in the board all along. A better term might be temporarily acid neutralized or acid delayed. While these less costly boards might be suitable for framing decorative items that have no long-term value, they're not suitable for long-term framing. For protective or preservation framing, the best boards are manufactured using only virgin alpha cellulose, the purest paper fiber. Cotton fiber is the best because cotton linters inherently contain almost no lignin and fewer impurities than wood pulp. Only minimal processing is required to manufacture alpha cellulose from cotton, resulting in relatively long fibers. These all-cotton mat boards, often called museum boards, generally have a lighter density and a softer feel than the boards made from alpha cellulose from wood. The next best boards are made with virgin alpha cellulose fiber from purified wood pulp. Compared to cotton, purifying the wood pulp requires more extensive processing to extract the lignin and other impurities, resulting in shorter fibers. So, boards made of alpha cellulose from wood are heavier and have greater fiber density. These are often called conservation mat boards. Both museum and conservation mat boards are made of virgin alpha cellulose, which means they are made from all or nearly all new fiber. Whether made from cotton or purified wood pulp, these alpha cellulose boards really are free of acid because lignin and other impurities are extracted, leaving only the cleanest, purest fiber. Some framers prefer to work with the softer, lighter weight cotton boards, and some framers prefer to work with the denser, more solid boards made from wood alpha cellulose. Personal preferences aside, both types of virgin alpha cellulose boards, whether from cotton or purified wood pulp, are equally suitable for protective framing applications. We also have boards that are called white core, which are made of mostly recycled alpha cellulose fiber. The difference is that the recycled fiber, which comes from the manufacturing scrap of other paper products, can contain impurities from the secondary processing. White core boards usually contain chemical additives too, like optical brighteners, which chemically react in a closed-up frame package, making white core boards unsuitable for protective framing. White core mats will not discolor, but because of their fiber chemistry, they're not much better than acid-free boards. Like the lower quality acid-free mat boards, most alpha cellulose boards also contain a high alkaline buffer in order to neutralize acids that could migrate from other sources, like the raw wood rabbet of the frame, or a fillet in a mat window, or ambient air, or maybe from the art itself. Some alpha cellulose boards are available without the buffer, and when organic items are being framed, like sheepskin, leather, or seashells, for example, then pH-neutral, unbuffered alpha cellulose boards are usually recommended, because some organic items react badly to a high alkaline environment. Zeolite, which serves as a passive molecular trap, further enhances a pH-neutral board's ability to neutralize impurities that could migrate or off-gas within the closed-up frame. Separate zeolite sheets can be added to the frame package, and some mat boards have a zeolite additive. The framing boards called acid-free are not good enough for high-quality framing. Instead, we use lignin-free boards made of virgin alpha cellulose. That's especially true for preservation framing. But even for framing items that have only decorative value, alpha cellulose boards offer the advantage of longevity. They're less prone to chemical reactions, less vulnerable to damage from light or moisture. They deteriorate much more slowly, and they keep their original appearance for a long time. In addition to the quality benefits of alpha cellulose boards, there's an economic benefit too. In retail framing, upgrading to alpha cellulose boards involves only a small extra price and earns more profit in the bargain. Whether the board is acid-free or alpha cellulose, the labor for cutting a mat is the same, and the cost of that labor generally exceeds the cost of the board. Upgrading to an alpha cellulose board costing, say, 60% more might amount to a price difference of about 20% for the mat, with a similar increase in profit. Here's an example. Let's say the retail price for an acid-free window mat is $20. That is, $5 cost for the board, $10 cost for the labor to cut it, and $5 profit. If the framer upgrades to an $8 alpha cellulose board and adds $1 extra profit, the retail price would rise to $24, which is a 20% $4 price increase. And profit also increases by 20% from $5 to $6. In a typical frame shop, the total retail price of a project like this might go from $175 to $179. And for the benefits of the better board, that's a pretty good deal. Until a few years ago, framers tended to stock mostly acid-free mat boards and a smaller selection of alpha cellulose boards. As the trends toward better framing and preservation have progressed in recent years, a typical frame shop's inventory may have shifted to mostly alpha cellulose boards, museum grade or conservation grade, and a smaller selection of acid-free boards. Many framers now sell only alpha cellulose boards and no longer stock acid-free boards. And that helps to raise the standards of our industry.